Okay, we're into lesson 5 now. This is geometric sequences. So we just finished arithmetic series and arithmetic sequence. So that was when we were adding to get the next term. Now we're going to be multiplying to get the next term. And you can consider the following two sequences up on this page. You can see that in I, it's just going up by 2. You're adding 2, adding 2, adding 2. That is an arithmetic sequence. We just did all that. Now we're stopped that, and we're moving on to this different section called geometric sequence. And geometric sequence goes up by multiplying, not by adding. So now we're multiplying by 2, multiply by 2, and multiply by 2. So obviously it's going to grow much faster, and it's not linear, okay? The growth is non-linear. Question? Yeah, go. Okay, so a sequence where each term is obtained by multiplying the preceding term by a constant is called a geometric sequence. For example, 3, 6, 12, 24 is a geometric sequence. How are we getting to the next term? We are timesing by 2. Good. So the value of the constant can be found by dividing the second term by the first, or by dividing any term by the previous, and these are some examples of that. So any term divided by the previous term will give you the constant that you're multiplying by. So in this example here, the constant is 2. Okay, they call that constant the common ratio, and we're going to give that a symbol of R. R is our common ratio, okay? So let's take a look at some of these examples. Explain why each is geometric. So 12 divided by 6, it would have to be the same as any term divided by the previous term, 24 divided by 12, and it would have to be the same as 48 divided by 24. And in all these situations, it is 2, right? So in this case, R is 2. You can see that the next term is gotten by multiplying by 2. Okay, let's take a look at the next one. Take the next term and divide it by the previous. This should be the same as the next term divided by its previous. And it should be the same as the next term divided by the one previous that. So in this case, what are all these ratios? -5. What happens when you multiply by a negative? The sign switches, right? So look at each term in this sequence. Notice the sign switch. Negative, positive, negative, positive, negative, positive. That tells you that the R value is negative. And you can see it's being scaled by 5. It's going up, multiplying by 5, multiplying by 5. And negative switches the sign. So in the first two examples, we were dealing with sequences that were growing. You can see in this next example that the sequence is actually decreasing in numerical value. So it tells you something about the R value. The R value is less than 1, ignoring the sign, of course. So in this case, what's -5 divided by a -10? Yeah, it's a half, right? 5 is half of 10. Okay, and this should be the same as if we were to take -5 over 2 and divide it by the previous term, which is -5. And this should be the same as if you took the next term, -5/4, and divided that by -5/2. Okay, you should get the same value. And in this case, the R value is 1/2. And if you don't believe me, you can always double check your calculator. So we're showing that these sequences are geometric. Okay. So for these next 3 sequences, please identify the type of sequence, whether it's arithmetic or geometric. State the common difference or common ratio, depending. And then state the 5th and 6th. So no formulas involved. Let's just pretend we're like in elementary school and we're working with patterns. So let's take a look. What is this going up by if it was arithmetic? No. If it was arithmetic. 16. So add 16 to 24. Do you get 72? No. So it has to be geometric. or it should, my senses are telling me it's geometric. So take the next divided by the previous. It should be the same as the next divided by its previous. And I'm thinking this is 3, right? So R must be 3, therefore geometric. Do you guys agree? All right. And it's just like we're playing with the math, no formulas yet. We're just playing around. Okay, let's take a look at this one. The fact that it goes from 36 to 0 tells me it's probably not geometric, because you'd have to times by 0 to make that happen, so this must be arithmetic. What are we subtracting by? 36. And remember, we don't ever subtract, we always add, so that was poor language on my part. We're just adding negatives here. Adding negatives to make the arithmetic sequence decrease. You take the next term and you subtract the previous. And this should be the same as if we took the next term and subtract its previous. And I'm assuming this is negative 36. So that's your d value, negative 36. That's your common difference. So arithmetic sequences have common difference, and geometric sequences have common ratio. Okay, because one's multiplication and the other is adding and subtracting. Multiplying and dividing, adding and subtracting, right? But we always just use the adding and multiplying. We don't typically subtract and divide. Okay, let's take a look at this one. I see fractions involved, so I'm assuming it's probably geometric. Okay, so take a term and divide it by its previous. Let's just stop here for a second. What happens when you divide a positive and a negative? The whole thing is negative. So I'm assuming that this is the R value, negative 2/3. Okay, let's just double check. Okay, let's check. So just check. Take negative 4/3 and divide that by 2. What's negative 4/3 divided by 2? Well, it's the same as timesing by 1/2. You get negative 4/6, which reduces to negative 2/3. Is that the same as what we had? Yes. So this is our R value, and it's geometric. Geometric R value. Okay, so now you're probably wondering, okay, what's the formula to make all this happen? And I'm assuming this is going to show up in this next page. Okay, consider the following scenario where you have this biology student studying the growth of a plant, I guess, and they're measuring days versus mass. Okay, and they've got the first 4 days listed in a chart. The masses form a geometric sequence, so they're telling you that it's geometric. They say state the common ratio. Okay, 12 divided by 8. What's that ratio? Divide by 4, you got 3/2. Okay, so this is my common ratio. 3/2 as a decimal is 1.5. Okay, so that's where this 1.5 is coming from. So your first term is 8. Well, how to get into the next term? Take 8 and times it by 1.5. You get 12. Okay, take 12, which is this guy here, and times that by 1.5, you get 18. And to get the next one, you times by 1.5 again to get 27. And you just continually just multiply by this common ratio R. So what's happening is you start at your first term, multiply that by R, multiply by that by R again, and you just keep going like this. So the next one will be AR cube, and then AR 4, and then AR. Okay, what's the pattern here? The power is always what compared to the n? 1 less. And this is very, very similar to your formula for arithmetic. Look at this. This should be like jumping out at you. N minus 1, N minus 1. Why? Because you start at the beginning. To get the next term, you multiply by R, or if it's this, you multiply by D. And it'll always be 1 less than how many terms you have. Okay? So it's very similar. This formula is on your formula sheet. It's right here at the bottom. And if you're new to the class, there's two sets of formulas that mean the same thing on your formula sheet. So if you're new, come get a formula sheet. Or if you've lost yours. Formula sheet, you got one? Okay. So on the formula sheet, there's two sets of formulas. One has T1 and one has A. So sometimes I use either. I bounce back and forth, but they just mean the same thing. Okay? Okay, so Tn is the general term. So that's going to be just some value, Tn. So for example, T4. What's T4? Well, it's the fourth one in the list. Okay, T4 is going to be some number, depending on whatever the sequence is. There's still 5 or 6 of you in the room that are confusing what that means. Okay, and I noticed it on the quiz. So, the Tn has a value. Okay, the N just tells you which position it's in. That has to be clear in your head. Okay. So if I told you that T5 was 30, what does that mean? The fifth term is 30. All right. To get these values, the first term is A. The second term is AR, because you got to multiply by R onto A. The third term is AR squared, because you got to multiply by R twice. And so on like this. Okay? Good. Class example 3. Determine the formula for the general term and hence, it's a big word, calculate the indicated term for each of the following. Okay. Tn equals A R n minus 1. That's the general formula from your formula sheet. We need to insert what we know. What do we know? Do we know A? It is 5. Okay, grade 7 review, bed mass. What happens when you multiply something with exponent? What do you do first? Okay, do your exponent first, right? Then you multiply. Okay, so what's the R value from 5 to 15? Good. R is 3. N minus 1. Why do I leave n there? Because the formula depends on it, right? Without it, you don't get anything. So in this sense, you think of it like this. F of x equals A R x minus 1. What does my formula depend on? X. And what does it spit out? Y. Okay, that's if we were doing real numbers with functions and stuff, but we're not doing that. We don't live in the real number world for this stuff. Where do we live? In the natural. And the naturals are only the counting, right? So 1, 2, 3, dot, dot, dot. Okay? So we don't typically relate it to our function notation, but it's very similar. You input an n, you output a. If I input x, I output y. But if I input an n, I output tn. Good. And tn has some numerical value. But n is just your counting numbers. 1, 2, 3, 4. It's the position in the list, right? N is your position in the list. Tn is the actual value of the thing in that spot. Does that make sense? You have to know that. Okay, what do they want us to solve for? T9? Too bad it wasn't T1000. Oh, Terminator. But it'd be sweet because it's Terminator. Okay. if I wanted to do this by hand, I would have to go 3 to the 8 and then get that value and times it by 5. If you start combining 5 into 3, make it 15, and then go to 8, you're just going to have no happiness. Okay? Do not do that. So, but if you have like the nice calculators, if you type it in like that, it'll do BEDMAS for you. You don't have to think about it, but you should know it. So what's this value? Somebody help. Fine, I'll do it myself. Oh, very large and it's hard to... 32,805? Brilliance, 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 brilliance. Okay. Was this sequence increasing or decreasing? Increasing. Because the R value is greater than 1. What happens when you multiply by stuff greater than 1? Gets bigger. What happens if you multiply by stuff less than 1, but of course bigger than 0? Gets smaller. Like that's what happens when you multiply by 1/2. Gets smaller, right? So let's take a look at this sequence over here. Is it increasing or decreasing? It's decreasing. 1/3, a 1/6, a 1/12. It's like you're continually cutting a pie into smaller and smaller pieces, right? Okay. So what's the R value? Not as easy as this one, eh? Oh, I could just times by 3. That R value was easy. Did it in my head. But this R value, unless you're clever, could be a bit challenging. It is negative something. Good observation. Because the signs are switching, right? Good observation. And what's happening to the denominators? Going up by 2s. And or it's being multiplied by 2. What's happening to the numerators? So it's 1/2. Yeah, negative. That makes sense? Because when you multiply fractions, it's like top to top and bottom to bottom, right? It's just integer stuff happening in the top and in the bottom. What's the integer in the top? Multiplying by 1. What's the integer in the bottom? Multiplying by 2. So the fraction would be 1/2. Of course, negative. To do that by hand, you'd go like this. Or to do this by algebra, you'd do it like this. The next term dividing the previous. Easily done on here. You put this in a bracket, you put this in a bracket, and then you press math fraction, and it'll spit out this. Okay? If you wanted to do the fraction stuff by hand, you'd have to go, okay, negative 1/6 divide 1/3. Negative 1/6 times 3/1. Negative 3/6 reduces negative 1/2. Okay? That's if you do the fraction stuff by hand. Okay? Easily done in the calculator in like 3 seconds. Especially on like a unit test where you don't need to show your work for some multiple choice question. You would do this on your calculator. Okay, so we got our R value. This is our R value. R is a -1/2. This is what we wanted. Once we have that, just make sure we start at the first term. Start at your first term. This is like kind of what guides the sequence. Where do we start? And then each successive term is found by taking -1/2 and raising it to some power n-1. Remember the formula? Tn equals a r n-1 as a power. So what you're looking at here, what do we want? T7? Okay, T7, 1/3, -1/2, 7. So for the 7th term, think about this. 1, 2, 3, 4, 5, 6, 7. To get from A all the way to the 7th spot, how many times do I got to multiply by R? 1, 2, 3, 4, 5, 6. Uh-oh, I drew too many. 1, 2, 3, 4, 5, 6. The 7th term. Let's just erase this and make it neat. 1, 2, 3, 4, 5, and 6 multiplications of R, right? That's what this says. 6 multiplications of r. So what's 1/3 times negative 1/2 to the 6th? Yeah, because 64 times 3 is 192. Good. Does anybody know where I got 64 from? 2 to the power 6. Right? 2, 4, 8, 16, 32, 64 in the denominator. 64 in the denominator times 3. 192 negative. Of course, can be done in your calculator if you don't want to do it in your head. Okay, I'll leave that zoomed in. Any questions so far on geometric sequences? Yeah. Oh, for power? Oh, math. Enter. One more enter. Oh, too ugly. How many? Okay, well, I'll show you guys on my calculator on the screen. Because I know sometimes you teach it and yeah, I just assume you guys can do this, but the calculator. So what do we have? A negative. So be clear with brackets. Negative, oh my gosh, negative 1 dividing 2. It was to the power 6, right? Math fraction. And then I'm timesing that by 1/3, right? And then you math fraction this. Now your calculator didn't like that right off if you did it all at once, right? So maybe try to break it down into parts. Yeah, the equation was negative 1, no, just 1/3, right? Times negative 1/2 was to the power 6, right? Oh, I forgot a bracket. So I can insert a bracket with second delete. And then math fraction. No, I did it. Mine did it. Okay? All right. So enough about the calculator. Let's keep rolling. Determining the number of terms in a geometric sequence. Okay, so this will be like you're solving for n. Okay, just like we did with arithmetic. They would give us some term value, but we don't know how many times it takes to get there. Could I just go on my calculator to figure it out? Probably. Type in 32. So we're doubling, right? You guys can see that we're clearly doubling. And we want to get to 16,384. So are we starting at 16? Hit enter. Times 2. Once, twice, 3 times, 4 times. It's 10 presses? Thank you. There it is. So you could just do it by screwing around on your calculator, right? So that's an option. Now, to do the proper math, I'll just need to show you a little algebra. Yeah, that's what we're going to do now. Yeah. Yeah, a little bit easier, yeah. Arithmetic. Okay, Tn is A, which is 32, multiplied by R, which is 2 to the n minus 1. Now this is what some of you were having trouble with the quiz. What is 16,384? Is it n or is it Tn? Right? Do not screw that up. Okay, so 16,384 is the term value. We want to know which position it's in. In solving algebra, you always isolate what? The term that has the unknown. Isolate term with unknown. Okay, so that's this. And it's in the power. It's really weird. Have you ever solved an algebraic question where the unknown was in the power? It's just weird, right? Yeah, you can't just square root it. You could nth root it, but there's a -1 in there, and then I don't even know what n is, so it's just bizarre, right? And in Math 30, you'll learn how to do it for any number, and it's called a logarithm. But we're not there yet. So for these, there's a nice little trick that I'll show you. Okay? So, and it just involves the exponent laws, which you guys know. So how do I isolate this term? What do I do to that 32? Do I subtract it? Do I subtract it? Do I subtract it? No. Do not be that person that subtracts in this case. Why is it not subtract? Good, this is multiplication in here, so I need to divide out. Okay, 16,384. Dividing by 32, I'm getting 512. Anybody know that number? Recognize that number? Anybody? Computer science kids would know that one. Powers of 2. Is 512 a power of 2? I always do this with my youngster. He's 9. He loves it. Count by 2s. By multiplying. 2, 4, 8, 16, 32. Do you hit 512? How many times does it take to get there? I always memorize. This one's memorized for me. 2 to the 5 is 32. 2 to the 6 is 64. 2 to the 7 is 128. 2 to the 8 is 256. And then 2 to the 9 is 512. Everybody can see that through my head? See that pattern? It's just consecutive multiples of 2, right? If you started at 0, 2 to the 0 is 1, 2 to the 1 is 2, and so on. That's a geometric sequence in its own right. Okay? So I can do a substitution. 2 to the 9 equals 2 to the n minus 1. So that is a pretty clever substitution. Now let's write that there. Clever substitution. Why is it clever? Substitution. What do you need to have the same here? It's like a base 2. Clever substitution with base 2. And think about equality. This equality. What does it mean to be equal? It means you have the same value, but you just look different. Does 2 look different than 2? I mean, 2 is 2, right? So what does that mean? What does it mean about 9 and n minus 1? That they're the same. Good. If 2 is the same as 2, then what's left to be the same? 9 must be the same as n minus 1. And then to solve this, it's just n is 10. Just add 1, right? So, what does this mean? Wow. Someone's chirping me out there. What does it mean, you guys? T10 equals 16,384. That's what it means. The 10th term is 16,384. You already knew that, though, right? You played that game with your calculator? Yeah, you already knew that. Okay, what I wrote up here goes down for B, so that stuff's for B. Now for C, you could, like if this is trouble for you, this logical trouble, you can use your calculator. So 512 equals 2n minus 1. All you have to do is type this into y1, type this into y2, and then you do an intersection feature. And that will also solve for n. It's in second trace. Do you guys know about this? So just so you guys are aware, any equation can be solved with second trace intersect. The left-hand side of the equation is y1, the right-hand side is y2. So your graphing calculator can help you cheat a bit. It's not entirely recommended though, especially in the -1 programming. If we're in -2, I'd say, you know, jump all over that calculator and use it. But in -1, you should be trying to do your algebra. Okay, geometric means. Remember this, geometric means? We did it with arithmetic, right? It was when you have to place a whole bunch in between. Okay, so let's insert 4 geometric means between 81 and 729. 1, 2, 3, 4, 1 over 729. So how many times would you have to multiply by r to get there? This one would be what? AR, right? The first one's A. The second one's AR. What's the third one? AR square, and then you keep going. What's the next one? AR3, and then the next one is AR4. So then this one is AR5. So from that, we know that AR5 equals 1 over 729. Do we know A? What's A? 81. So 81 r to the 5 equals 1 over 729. So isolate r to the 5. So where does the 81 go? You have to divide out 81 on the left, right? So it's going to go down here. 729 times 81. I don't even want to know what this is. 59049. Okay, and just like in Pythagorean theorem, when you have, you know, something squared equals something, you square root it. In this case, we don't do a square root though, we do a fifth root. How to find fifth root? It's in the math button. But then it's got an X in there. It's really weird. You see that? You have to find this in the math catalog. X. This thing in the math catalog. So you actually have to type in the root first, and then you hit this X root radical, and then you can type in this 1 over 59049. So it's the fifth root. So you have to hit 5 first, and then math, find it, and then you can type in 1 divided by 59049. Math fraction, I'm getting 1/9. You could also do it this way, just the fifth root of 59049, and you get 1 over 9. Did you get like 0.111111? Yeah, that's math fraction 1/9. Okay, so to insert these geometric means, all we have to consecutively do is multiply by 1 over 9 consecutively. So 81 times 1 over 9, I get 9. times by 1 over 9, I get 1. And then I get 1/9. And then I get 1 over 81. Okay. Yay, math, right? Me and Chi Ming love math. We're going to form the math club in East Glen. And everyone's going to join. No? Square root chess. You come up with that, I'll play it. Okay, let's take a look at the next one. Do you guys recognize this style of question? Especially from that quiz, remember at the beginning? Yeah, you recognize it, right. Good, keeping track of your work. So what do? You take the next term and what to the previous? Divide it. So we have 3 consecutive terms. So to find R, you take a term and divide it from the previous term. Would that give you R? Is there another way I could find R? No. Just what? No, we can't use slope thing. That's arithmetic only. You have to use another term. Good. X minus 5 over x, right? So the second term dividing the first term, or the third term dividing the second. Because they both equal R. If they both equal the R, what do they equal for themselves? What does this tell us logically? If they both equal R, they equal each other. If they both equal R, they equal each other. And right now I'm scared. You guys scared? Or are we confident? Kids in my physics 20, how do you solve this kind of fraction equals fraction? What did we do? Remember the P1, V1? What did we do? Cross multiply. Okay? So, we're solving for x. There's only one x. Okay, so we cross. You guys, you cross. Anytime you're in a fraction equals fraction situation, you cross. So x times x is x squared. And then over here you get, polynomial review. You have to FOIL that polynomial. All right. We got x squared. We got 3x. We got negative 5x. And we got negative 15. This should be no problem for a 20-1 student. Okay. Okay, so you have an x squared on the left and an x squared on the right. Imagine you had a balanced scale, right? With some weights on each side. Say I had a 5-pound weight and a 5-pound weight on either side. What if I picked them off and dropped them somewhere else? They cancel each other out. Would those even affect the scale? Say I had 20 pounds on each side. So is it balanced? Okay. And I had a 5-pound weight and a 5-pound weight. If I both took them off, are they both 15 still? Yeah, so that's what we'll do here. Let's subtract away x squared. Subtract away x squared on both sides. Subtract x squared, subtract x squared. They're gone now. What do you have on the left? What do you have on the left side? Nothing, so you put a 0. What do you have on the right side? 3x minus 5x is negative 2x minus 15. How to solve this? Move the 15 over here, switch the sign, divide by negative 2. negative 7.5 equals x. Oh my gosh. Okay, we now have x. So x plus 3 is generating the sequence now. X plus 3 would be negative 4.5. X is negative 7.5. And then x minus 5 would be negative 12.5. So I think this is my sequence. I just used x, the value for x, 7.5. Right? X is negative 7.5, so I added 3, kept it the same, and then subtracted 5. You'll be balancing equations for a long time in your math life. Okay, we have much success. All I did there was I double checked that this was geometric. I took 7.5 and divided 4.5. I took 12.5 and divided 7.5. Did I get the same thing? I did. There's probably one in your homework just like it. Okay. The fourth term and the seventh term of a geometric sequence are negative 54 and 1458 respectively. Please write that down. Translate that. T4 equals. Okay, keep going. Do the next one. Yeah, I just need to take a breather here. Okay. You have this written down. T4 equals negative 54. And T7 equals 1458. Okay, so what does that look like? Negative 54. 1, 2, 3, 4, 5, 6, 7. Here's T4. Here's T7. What's the formula for T4? What would be the formula for T4? A, right? That's here, right? How many jumps of R? 1, 2, 3. I got to multiply by R. How many times? 3. So there's that one. Okay. What about T7? What would that one be? A, R, 6. Okay. So, term 7 divided by term 4 would be AR6 divided by AR3. Do you agree? So the A's cancel, and how many R's left over? A 3, right? Whoever said a few, I guess you're technically correct, because a couple would be 2. Okay, so it's R cubed. Does that make sense? How many jumps from T4 to T7? So does it make sense to get from here to here? You would have to multiply by R 3 times. And what is the value of T7 divided by T4? 1458 divided by negative 54. Is it negative 27? So we have this, good, Chi-Ming. We have this negative 27 is equivalent to r cubed. So you cube root this. We cube root this. And we get negative 3 equals r. So now I know the common value of r, negative 3. So I'll take 54 negative and times it by negative 3, I get 162. Times that by negative 3, I get negative 486. Times that by negative 3, and I got 1458. Woo! Now I'm just going to go backwards. Negative 54 divided by negative 3, I get 18. And divide that by negative 3, I get negative 3. And divide that by negative 3, I get 1. So there's my sequence. And they want the formula for the general term of the sequence. So the formula for the general term of the sequence would be Tn equals A r to the n minus 1. A is 1. R is negative 3. So Tn multiplying by 1 won't do anything, so it's just negative 3 to the n minus 1. Can I move it up? I cannot move it. I can zoom it in a bit. Oh. Did I screw up? Oh, Chi-Ming, you have to be careful with me. What did I screw up? I wrote it down wrong, hey? My brain went too fast. But thanks for catching. This should be negative 6, right? And then 2, right? Is it 2, Chi-Ming? All right. So we need to go back in here and change this to 2. Okay? 2. I thought I was done, but I wasn't. Okay, so there it is, all better.